Let's kick it off with the last lesson for Unit 10, 10.4. It's exponential modeling, but we're talking about day 2. So day 2, we're going to focus a lot on decrease. So your objective is to write an exponential function when there's a decrease over time. So exponential function can be both increasing, like we saw in 10.3, and decreasing, whether their base is greater than 1, which means it's increasing, or if it's between 0 and 1, that means it's decreasing. Now, there are some scenarios in real world that can describe using these. The first example I want to take a look at with you is about a radioactive substance is decreasing such that 2% of it is lost every year. This is known as a radioactive decay. Originally, they were 200 kilograms of there were 200 kilograms of substances. Now, how much material remained after 1 year? Now, the first thing we need to do, just like we did in the previous lesson, is to make this into a decimal. This is actually 2.02. So how much did it decrease? So it was 200, and then for 1 year it decreased by 0.02. This actually works out to be 4. So if it was 200 and it decreased, which means I'm subtracting 4, then do I have left over is 196 kilograms. By what single number could you have multiplied this by? So remember, how did I get this answer? I had a 200 and then I subtracted 200 times 0.02. Now, if you look at this expression, they have a 200 in common. I take that out, and this left with 1 minus 0.02. Minus came from here. So then this actually becomes 200, 0.98. So the question says, what single number could I have done this with? If I multiplied the 2 by 0.98, I could have also got the 196. Now, to use this data, how can we find an equation A of t such that to model this, I am starting with the 200, and then I am going to have that 0.98 to whatever t, however many years that is. Now I have this, I want to go to my calculator. And the next question says, use the calculator to determine the nearest half-life of the substance. Now, half-life of the substance, that is, it takes how long it takes for only half of the amount to remain. So I am looking for half of my starting, which is half of, what am I starting with? Half of 200. So I'm looking for somewhere my half time, not half time, what am I? My half-life. Oh, my half-life is going to be 100. So let's go back to our calculator, enter this in the graph. So my original function that we said was 200, and it was 0.98 to the x power, oopsie, to the x power. Hit enter. That's okay. Table, split screen, I don't care. I want to know when is this going to be 100. So we're going to go down, go down, go down, go down, go down, all the way until I get close to 100. Look at this. At 100, it is somewhere between 34 and 35. Now, 35 is way too much because at 35, I'm only having 98.6 kilograms. I want it to be 100, somewhere closer. The closer to 100 is 34. So when this question say about using the table, how long, we're going to just have to say 34 years. So at 34 years is going to be somewhere around my half time. Now looking at this is very similar to increasing functions, is I have my starting just like I did when it was increasing. Now it's 1 take away the percent because it's decreasing and everything else remained the same. So let's look at this. If the population of a town is decreasing by 4% per year, and it started with 12,500 residents. Which of the following is a projected population in 10 years? Now, what I need to do is write my equation. So it's 12,500. It's 1 minus 4%. Remember, it's always as a decimal. Same thing apply to the 10th year. Put this just like that in your calculator. You actually get 8,310.407, which is approximately 8,310. It's choice number 4. So it's very similar. Now we're just doing subtraction because it's decreasing. Now, exercise 3, it says, hydrolysis have found that the amount of water that a soil can absorb in inches per hour decreases by 30% each hour that the soil is flooded with water. A particular dry soil is initially able to absorb 4 inches of water per hour. Write an equation now. Starting A of t, this is my starting A of t. It says they can absorb 4 inches of water, but then after every hour it decreases by 30%. So it's going to be 1 take away 0.3 to the close parentheses to the t power. So then this simplify would actually be 4.7 to the t power. You can add the 0. So this is actually my final. This is my starting. It's decreasing by 30%. B says sketch and label your graph. So when we label, I want you to look at this as 4. This is 10. And I want you to start, because this, why is this 4? Because that's what my starting point right here is. Okay? So you should have a graph when you sketch this that looks something like this, with a little arrow there. And make sure you label your graph. This should be y is equal to 4, 0.7 to the t. Now it says, a steady rainfall of 0.5 inches per hour is flooded in the soil. Water will run off the soil when the rainfall exceeds the rate at which the soil can absorb. At what time to the nearest tenth of an hour will runoff start? Show your solution graphically. So I'm asking you, what, this is 0.5. What is this point right here? When it comes down, what is that point right there? Now, you can set the graph up. You know your final answer needs to be 0.5, and you know what the equation is. 0.7 t. This is multiplying. So what do I want to do? The inverse of multiplying is actually dividing. Excellent. So I'm going to divide both sides by 4, and then what am I going to get? Tell me. Work this out. You have no idea? That's fine. Now, let's go ahead and put it in the calculator. That's how you find it, if you can figure it out. So, I want to clear this that I just did, and then I want to go back to my graph and enter my function. My function was 4 parentheses 0.7 to the x. It was something like this. So I want to know when is, and let's check the table. So I want to go to my window settings, and then I want to do the settings. So my minimum is 0, 10, 10, 10, 0, and this is 4. So I am looking for, when is my y value 0.5? So I can go to menu, and I can do a graph trace, and I want to find when it's really close. So look at the numbers here. I want this to be 0.5. So if you notice, when I keep going up, 5.7 is just about right. So on my graph, where are we? Here is actually, we can say 5.7, that's fine. So in t equals 5.7, it's approximately, so not equal to, let's just say we're approximating this, because it was like 5 point something something. 5.7 hours that's when it's going to be at 0.5. Now the last lesson, that last exercise, let's see how this is worked. The stock price of Window Power Inc. is increasing at a rate of 4% per week. Its initial value was $20 per share. On the other hand, Gerbil Energy is crashing, meaning it's losing the value or it's decreasing at a rate of 11% a week. If the price is 120 per share, when Window Power was at $20, after how many weeks are they going to be the same? Show the equation that you're using to solve. So the first thing, let's take it piece by piece. And let's write this. I am working with Window Power Inc. These are the one I know that's going to go up. They're increasing. So they started at 20 and then they had an increase of 4% per, 4% per week. So here, where we go. So this becomes 20, 1.04 T. Now this is Gerbil Energy, and these are the one that are actually decreasing. So they were at 120 and they are decreasing at what percent? 11%, so it's 1 minus 0.11 to the T, so it's actually 120.89 to the T. Now these here, 1 and 2, these are my two equations. 1, 2. I'm asking you that when are these two equal to each other? Question say if the prices are at this prices, how many weeks will these stocks be the same? So I'm basically saying when is 20, 10, not 10, 1 point, sorry, when is 1.04 to the T equal to 110, 120, 0.89. When is this happening? When is this true? Now it says show the equation you're solving and then solve it graphically. So we don't have to solve this by hand. We just need to solve this and find the intersection. So I want to know what is the value of T. Get your calculators again and let's clear this out. Remember how to clear it. Document B as in boy. So we're going to enter two graphs. The first one I had was 20, 1.04, and remember we're raising this to x. And then the other one, don't worry about it not showing up, is 120.89 raised to the power of x. Enter. Now let's fix this up. You have to be able to do this and fix your table. So go to, go to menu. I want to go to window settings. So I want my x minimum to be 0. The maximum is going to be 20. And how do I get these numbers? These are numbers I started with. Then I want my 0. And this can be 130. Because why didn't I could have put 120, but it doesn't really matter. So basically, let's move this out of the way. I want to find what is this intersection right here. So I go to menu, I go to analyze graph, and I go to intersection. Okay? And then you see it says right here, it says lower bound, meaning I want to go to the left, click on it. It should change to upper bound. Click on it and it tells you your intersection is at 1.5 comma 3.14. So that's what I'm actually going to screenshot it, but this is what you should be sketching and putting this graph with the intersection onto our paper. So I'm going to extend this and bring my screenshot here. This is what you're sketching. Oops. This is what you're sketching onto your paper. What is the value of T? So T is actually the first letter here. So T is 11.5, which is approximately 12 weeks, because we were dealing with weeks. Okay? And that's it for today's lesson. You have made it to the end, so you got to go ahead and get the study guide for Unit 10, and then you know what to do after that. Keep up the good work, guys. I'm extremely proud of you. Good luck.